programs such as this EIME, I can't
We don't know either.
but what I did would have most likely fallen into this program now. Graduated back in 2007, spent 5 years teaching at the State University of New York College at Brockport, which is near Rochester. And I joined the faculty in the humanities last January to run the digital humanities program there.
I'm Bethany Owen. I'm just from upstairs.
Devin,
Yeah.
B-E-T-H-E-N.
A-N.
Well, this is great, right in front. So, we welcome you on here. TJ, it's all yours.
Holly asked me to let you know that she's taking track.
Okay.
She should be.
Okay. Go ahead, TJ.
Jeremy, it's good to see you again. I think it's been since open that.
Yeah, it's been a while. So awesome.
So thanks for coming. All right, so I've been working feverishly on a dissertation over the last 4 weeks, and I'm happy to report that chapter 5 is in Dr. Sublig's hands right now.
He was working on it before 4 weeks. It's the feverish part. 4 weeks.
No, just 4 solid weeks. I didn't touch the stuff before that.
Now I have to ask, is it the inspired version that he gave you?
No, he's working on the inspired. Chapters 1 through 4 are now inspired. Chapter 5 is lacking. But anyway, I'm going to present to you an hour's worth of this. I imagine that I'll condense this down to 10 minutes worth for my defense. Just so you know, this is not what the defense will look like. But you're welcome to come to that. We're hoping it will be Friday, February 1st from 1 to 3 p.m., but we haven't scheduled it specifically yet. But you're all welcome to come if you want to see how the defense goes. And Dr. Olson is on my committee, so he's somebody if you're interested in measurement and other things you need to know. So, anyway, the title of my dissertation is Toward a Model of the Quality of Digital Textbook from the Perspective of College Students. The towards in there is an interesting word. It allowed some wiggle room in what we could accomplish because we didn't know how far I could get with the data that I would have. So that's something. You'll see that. I'll start with a quote from John Dewey to kind of tie and bookmark my experience in EIME. EIME started with John Dewey. I thought I should end there. Just about the purpose of education and what I think the purpose of education is. There are 2 main purposes of education in my mind. One is the enrichment of the individual, which is what John Dewey talked about at length. And 2 is the betterment of society. And Derek Bach, who is the former president of Harvard University, talked about how the goal of education and the purpose of especially higher education is to concern themselves with society's problems. And the question is whether the universities and the education system is doing that is something that should be paid attention to. So just sort of some front matter about where I see the bigger picture of what education is about. Some data here, some things that have been going on in education. We've seen some rising costs. The cost of college tuition has been rising very fast, faster than medical care, and faster than all items which were included in this analysis. The cost of textbooks have also been rising significantly. So when you compare the cost of educational books and supplies, this is in higher education, compare it to the inflation in home prices, you get an interesting picture here. A lot of people are starting to see the rise in cost of educational materials as a serious problem, as part of the larger problem of the education bubble that people like Clayton Christensen have talked about. So some people, a lot of people have been trying to tackle this problem or find solutions or find ways to help students afford college and promote college. And one way of doing that is by using open educational resources. Openly licensing resources, these educational materials to to reduce the cost, and 2, to improve their quality or have more control over what content is given. But one of the reasons is to improve cost. And to help, like Professor Bach or President Bach said, to discharge the responsibility that we have as educators more efficiently and more effectively, open educational resources can be used for that. Another advantage of open educational resources, in addition to reducing costs there, can customize these resources on the ground, which is something that when the cost of printing a textbook, the cost of changing a printed textbook 20 years ago was astronomical. I mean, even if there was an error, a printing error, to reprint all those textbooks to make that correction was extremely expensive. But with the rise of the digital age and digital content, making those corrections and revising and adapting materials quite a bit cheaper, and it makes it possible to customize this material for the needs of particular classrooms or particular demographics, which wasn't possible either. You think of a faculty member choosing a textbook. They have to choose between what's available to them, and they get it wholesale. And I don't know if you've ever had a class where the professor stood up and said, or you saw in the syllabus that you're going to be skipping chapters 5 through 10 or skipping chapter 6 because it's not relevant to what they wanted to talk about, but it was the best fit that they could get. Open educational resources like this textbook from Flat World Knowledge, the faculty member or the teacher on the ground can make changes to that before the students ever even have to see it. So they only have to purchase or acquire the material that they need. One way that this can happen, one way that these books can be customized is on a continual basis. And I love this analogy here. You have the professor over here, and you have the student who really respects the professor. And the professor is paying attention to student needs. If the student will provide feedback about the instructional materials that they're using, the professor, the faculty member, the teacher can make changes to that resource to improve it for the needs of the student and give it back to them. So this is sort of the process of ongoing customization that digital content in general allows, is especially made possible through open licensing, where copyright privileges allow for someone to make changes like that. I mean, the fact that something's possible is one thing, right? That you can actually change stuff, but you can't just go and take digital content that's proprietary and make changes to it and give it back to your students as easily. There are some fair use contingencies that you could wade through if you wanted, but open licensing makes it clear how you do this. So the question really here that I'm addressing relates to this interaction here, the interaction between the student and the teacher in providing that feedback. What kind of feedback is useful? What do students think about their digital textbooks? And what is quality in the mind of a student? That's really the major question that we're asking here. So there's a good comic that goes with this. Here's Dilbert. He says, I like to have opinions, but not informed opinions. It takes so much work to get informed that it defeats the whole point of having an opinion in the first place. So Dilbert says, what exactly do you think is the point of having an opinion? The point is that it feels good. That's totally nuts. Oh, is it? Unless you have hard data to back up that comment, it was nothing but an uninformed opinion that felt good. He says, you're starting to make sense. Your whole life is a lie. The point of this, though, is that I wanted to get at the student opinions about their textbooks. And generally, when decisions are made about what textbook to use, what textbook maybe to buy next semester, I don't know how often faculty use their students' input to make those decisions. But the pilot study that we did with faculty members who were using open textbooks, all of them, every single one of them said that student feedback would be important to them in making decisions for updating and revising their open textbooks that they had, their digital textbooks that they were allowed to revise. So that's sort of the justification for wanting to get student opinions.
I just did this week. Not with an open textbook. I teach some classes that I don't use a textbook for. It's all open resources. And I did a survey of students, gave them just an interest scale and 20 things we could talk about that I could work into the syllabus. And when I presented the results yesterday, I said, you don't know what you want.
Yeah.
Because what they wanted, mainly what they were highly interested in, was aspects of application. Teach me how to do stuff. And what they rated as low interest were all the theoretical perspectives, the whys and the so whats. And so while I was able to integrate some of their feedback into the syllabus, be interested to know if you got any of that kind of comment from the faculty as well. How did they filter between what the students wanted and what the faculty knew they needed?
Yeah, I didn't ask them that directly, but it's a really important point to make here. This is student's perspective is one perspective, and you're exactly right. One of the problems is students may not know what they want. And the point of my study was to get at, and I'll talk about how I did this, talk to a lot of students across a range of textbooks. I'm trying to pull out those common, more global things. And we didn't get into the nitty-gritty like that. Do you want theory? Do you want application? Do you want things like that? But those are important, I think, next steps in getting at this. And one of the goals of my research was to using the student feedback and then combining it too with the literature on textbook evaluation. Find those things that would be common across the board, that the students do recognize as important, but also that faculty recognize as important. But in all of this, I mean, the ultimate decision for what revisions need to be made and what textbook needs to be selected is going to come largely through expertise on behalf of the person who has the expertise, right? The argument I'm making is that despite that, it's not okay to ignore student perceptions. And you're obviously an example of someone who said, I want to know what my students think about it. And then you can make that judgment. So, great points. And that's actually something that I need to add to chapter 5. So, I'm going to talk to you about the birth of a textbook quality measure and a model. This is actually a holdover slide from a presentation I gave when I wasn't as far along. But the point is I'm going to collect data to back up student opinions about the quality of their open digital textbooks. And this is the model that I'm going to use. So, and I'll walk through really quickly the method. We use student surveys, student interviews, and a literature review to understand what it was, the main aspects of quality of digital textbooks that students perceive. And that was all clumped together into an amorphous bit of qualitative data. Which then I subjected to a qualitative analysis known as thematic analysis, which produced out of all of that data some target themes, some global themes about quality of digital textbooks from the student perspective. And then those themes were subjected to mental modeling in my mind and others to result in a conceptual model of how these themes relate to each other, and also to allow for development of questionnaire items that could help us confirm or disconfirm this conceptual model mathematically. Okay? So the item development process led to an initial questionnaire that we gave to a bunch of students using digital textbooks that allowed for analysis of the model using factor analytic techniques. And I call that that's the quantitative data that we ended up with, which allowed for modification of that model, this conceptual model down here. Using the quantitative data, we could make modifications to that model, which would lead to a modified model. Then we could evaluate again using factor analysis and iterate until we got to what we think is a preferred model. So this is the structure we're going to go with. So I'll talk to you first about this process here. So the context of the study was a project called Project Kaleidoscope, an initiative of open digital textbooks, mostly digital textbooks, in 8 community colleges and 4-year schools. There are 8 total institutions. 2 of them are 4-year schools, and there are 2 of them in New York, 1 in Nebraska, and the rest are in California. These universities or institutions, colleges serve over 100,000 students, and there were quite a few people involved in Project Kaleidoscope, about 40 faculty that developed textbooks collaboratively, and then I think there were about 4,000 or 5,000 students involved. And so this was our population that we were sampling to get a look at perceptions of digital textbook quality. So note the limitations here is that we're not looking at university students, we're not looking at K-12 students, we're not looking at liberal arts college students. Mostly these students are actually high-risk students. They're people who've either come back to school who are high risk of dropping out because they can't afford school anymore, because they're working a job and they have kids, and all of those sort of factors are playing into this. The Project Kaleidoscope consisted of cross-institutional faculty teams developing textbooks and other materials for specific courses like business and math, and Jared, what else do we have? English and biology. And then they would aggregate these OER-based textbook replacements, what they call them. A lot of them came from Flat World Knowledge, not all of them, resulting in 11 courses, about 9,000 students in 2011 and 2012. So the initial survey, and this is the qualitative data, trying to get a look at what students think about their digital textbooks and what they think are the important characteristics of digital textbooks. We had 365 students who responded to these 2 questions, these 2 open-ended questions. From your perspective, what are the characteristics of a high-quality digital textbook? Get at it directly. Tell us what it is. And you make a good point, maybe they don't know, maybe they do know. So the key here was to look across all of them and see what came across in common. And then also we use this overall, what did you think of the digital textbook using your course, so they could draw on experience that they'd had with the digital textbook. And then here are the sample characteristics. We have actually pretty good representation across the 8 colleges for this, and across the genders as well. This was for the qualitative study. Of those 365, 10 of them agreed to do interviews. And I held 30-minute interviews with these 10 students and probed more deeply into the responses that they gave, and also asked them to elaborate on what they thought about their digital textbooks. And then those were transcribed, yes.
Did only 10 agree, or, I mean, how many did you offer? That's my question.
Well, we had enough money for 10.
Okay, all right, so you just got the 10 that...
We got 10, yeah. We had a few more than 10 agree to do it, but we didn't have the money to, because we remember we offered them something to do that.
So how did you choose the 10?
They self-selected. So at the end of the questionnaire, we said, if you be interested in or willing to participate in an interview, we'll pay $15.
And then you just chose those 10 randomly?
No, we chose the first 10 that
Oh, okay.
responded. So we were constrained by, this is something to consider, especially as graduate students, how to get people to participate in your study. I was lucky to have somebody willing to pay $150 for these 10 interviews. I also looked at the literature on textbook evaluation, and ended up with about 75 journal articles related to textbook evaluation across the board. K-12, higher ed, related to lots of different things. I only kept peer-reviewed articles, and that resulted in 9 or 10, actually 10 textbook evaluation criteria that came out of the literature. Now that's from the expert's perspective. This is what we feel students need to learn, and what should make a high-quality textbook. All right. So that's it for the collection of the qualitative data. The analysis of that qualitative data involved thematic analysis. I don't know. I did list the steps here, which result in those target themes. So there's 7 main steps in thematic analysis, data prep being a large one. But then you read through the data once or twice to get a feel for it. Then you start sorting out the data according to themes that you see coming out of that. You write about those things, you keep notes on those. You go back and do axial coding. So once you write what you think those things are, you go back and compare what you felt you saw to a new fresh reading of that. You sort it some more, refine those things some more, and then you finalize those themes by titling them and giving them a definition and including quotes that represent those themes out of the data. It's a fairly standard qualitative analysis approach. Very different from many of the quantitative approaches that perhaps you're used to. But it resulted in 8 target themes that came out of this data. Themes related to navigation through the textbook, accessing the textbook, features of technical performance of the textbook, interaction, meaning interactive features of the textbook, relevance of the textbook to things like the course and the assignments and the world in general, aspects of presentation, what things were not present in the book, and impact on student perception of their outcomes, so impact on their exams, on their assignments, on their tests, just overall educational impact. And then lastly, sensitivity to diversity. Now, a few of these came out of the student responses and weren't found in the literature at all. Navigation, access, technical performance, even really relevance didn't show up much in the literature. Aspects of presentation, especially the content, showed up in the literature a little bit. Impact showed up in the literature a little bit. Diversity showed up in the literature, but actually didn't come out of the student responses at all. And the reason I retained it is because of all the things in the literature, this was one that students should be able to weigh in on, is how they feel, how sensitive their textbook is to their unique situation, to their culture. So that's why it was retained. And then interaction was also in the literature a little bit on ways that interactive features of a textbook, whether a printed copy or not, could impact learning. So those are the results of the quantitative or qualitative analysis. Which once we had that once we had those themes, then I could start doing some conceptual modeling and end up with a conceptual model. Now the way I did this, because of the way I think, program sort of approach, which I understand is not technically a mathematical model until you've estimated it and got some numbers, but it's a way to depict mathematical relationships or relationships that you can evaluate mathematically. And one of the main reasons for doing this was to posit relationships among the constructs, among those themes. How are those themes related to each other? The first model looked a bit like this. I didn't have all the arrows in it at that time, but what I wanted to do was show these 8 themes in a mathematical relationship that could allow for measuring these themes and confirming whether they exist. And so these items, it's a little out of order because I haven't developed them yet, right? But these are the themes that I want to develop items for, so that I can measure it. And then, importantly, what are the relationships among these themes? And the relationships that, after reading through the data and thinking about this a lot, that I hypothesized were that these 4 factors over here, navigation, access, technical performance, and interactive features, all are related to each other because they all deal with the digital nature of the textbook. But they don't deal with, you wouldn't worry about any of them in a printed textbook. These 4 themes over here, though, would relate to anything, any textbook. Relevance, presentation, impact, and diversity. And so I predicted that those would be separate themes. And I hypothesized that there would be these 2 higher order factors, technology and content, is what I'm calling it. So these are the hypotheses that we've gone with, okay? So that's those are the conceptual models which allowed for item development to confirm or disconfirm or evaluate, explore those models, and to an initial questionnaire. So item development involves several steps. One, writing those items specifically to measure each of those themes. So I tried to write 4 or 5 items for each theme. And then reviewed those items with an expert after some weeks, made revisions to those items, and then conducted cognitive interviews. Now, some of you were involved in those, so I appreciate those who wanted to do that. Cognitive interviewing basically was an attempt to get at the mental process the students were using as they read each of these items. It's a way to improve items and make sure that they're functioning the way you think they are before you ever send them out. And so these were interviews that were conducted out loud, and you would read the question out loud and then walk through the process you were using to answer the question. And resulted in quite a great bit of information on how to revise the items and their ordering, and maybe how this item is interacting with that item to be confusing or not. And then more expert review of the final items and more revision, resulting eventually, finally, ultimately, in an initial questionnaire, right, with 44 items, measuring these 8 target themes. I administered this in October of last year, and we had 235 respondents. It was in the same study contest, the Project Kaleidoscope, but the next round of Project Kaleidoscope, the fall semester. So here I did it using Qualtrics online. So here's some examples of some of these items. How accurate is the search function in your digital textbook? That's item 2. How useful to your learning are internal links? How useful to your learning are page numbers? Those are sorts of questions that we had there in this initial questionnaire. The response that we got from students wasn't quite as uniform from the institutions. One reason for this was that Project Kaleidoscope wasn't being as closely overseen by the people that I'm connected with. They were kind of taking there was many students doing it, but they weren't having as much interaction with researchers. And so it took quite a bit of tooth pulling to get students to respond, quite a bit of follow-up. But we were able to get 235 respondents, and they came from Cerritos College mostly, and from Santa Ana College. And Cerritos College, by far, is the most participatory member of Project Kaleidoscope. I would say 50 to 70% of all students in Project Kaleidoscope come from Cerritos College. So I don't see this as big a problem as maybe it might look, mostly because we have the highest representation from the institution that has the highest participation. There's actually quite a few courses and textbooks and different things being used at Cerritos College. So we weren't focused on a single class or a single subject. We had multiple textbooks and multiple classes. Unfortunately, I'm not able to identify exactly what those were because the questionnaire didn't allow for that and other IRB issues. But we do know that those were fairly representative of a wide range of students and courses. So that leads us now with the initial questionnaire responded to and 235 respondents that we can start evaluating this conceptual model over here that I hypothesized. The conceptual models, really, the first order model and the second order model that explains the relationships among those factors. And this is an iterative process like I talked about before, using factor analysis. Before we did factor analysis, though, I did use item response theory, which you should know by now is related to factor analysis. But I use the graded response model, Samogina's model. Does that give anybody chills to hear it again? Did you get it? Did you get to the graded response model this last year? Okay. Well, anyway, I use that because I have polytomous data. I don't have continuous data. And that was just to check the items and see how they were functioning, just in general. Before I tried to use them to evaluate a model, I wanted to know, were there any really bad items that maybe didn't need to be included in the analysis for whatever reason. Then, I really appreciate the input from Dr. Olson. We were talking about this, and I already started analyzing and model evaluating, and he got looking at my question. He said, well, there are quite a few items there that you have where the students can opt out of answering the item because perhaps some feature of their textbook wasn't there, and so they couldn't. It does not apply to them. And so we had a long discussion about how to handle does not apply, and then I had some time in the literature looking at how to handle does not apply. And so I'll talk to you about how I handled this. It was fascinating measurement questions here. Then I evaluated the first order model using CFA, and then I evaluated the second order model using CFA and ECFA, exploratory confirmatory factor analysis. I'll talk about those in a little bit of detail. So I got to figure out how to make these figures better. If anybody knows how to get better figures out of IRT Pro, that would be helpful. So I can't get these to show up very well. I built these borders myself, but the internal lines don't look very good. Maybe I should trace them. Anyway, there were a few items that most of the items look really good. Particularly like this, where you have good categories, well defined. The students are responding in each category very well, and they have good category probability curves here. On the x-axis is theta, which is students' perceptions of the quality of the digital textbooks and then the probability of answering in that category. But 3 items didn't look so good. Had very flat curves, not well-defined categories. Interestingly enough, all of these items had reverse wording on the questionnaire. So every other item, option A was an indicator of poor quality, and option whatever D or E was the indicator of the highest quality for that particular whatever it was the question was about. These 3 items, though, were reordered, partly because of the way the item was worded, and it's not as it was sort of a subtle change, but I made a conscious choice to reorder those actually so the items would look more parallel to the other items. But the option A now is an indicator of highest quality, and option B was an indicator of lowest quality. For instance, one item read, how biased is your textbook to your worldview? And in that case, option A was very unbiased, which is an indicator of high quality, but reads as low as a negative word, unbiased with an un in front. So those are some reasons we chose to do that. Looking back on it, we had a discussion about this today. Probably would have been better to not do that. To have left those items in as they were. But either way, since these items were functioning so poorly, we removed them from the analysis going forward, and we're left with 41 items to analyze with our 235 cases. Now, how to handle the does not apply option. There were 22 items, so good over half of the items had a does not apply option on it. So this is a very serious consideration to figure out how to treat these options. And there are several different ways you can treat the options. One of them is to treat the does not apply option as meaningful within the continuum of the scale. So, for instance, the question that reads, how useful to your learning was the search function in your digital textbook? Option A is, there was no search function. Option B is, not at all useful. The question is, what's the difference between there being no search function and a search function being not at all useful? To treat it as meaningful within the scale, you could either treat it as there being no search function is worse than it not being at all useful, which which doesn't make a lot of sense to me. Or you could treat it as the same as not at all useful. And it not being there, not being at all useful, it's still not useful, right? So there are two ways to treat it as meaningful within the scale. If you can justify it. So that item is pretty clear how you can justify that one. There are items that's not justifiable. Another way to handle it does not apply is to treat it as missing data in a pairwise fashion. So a student who answered does not apply on an item, you would omit that response, but you wouldn't omit all the other responses for that student. You would just omit that one and code it as maybe something like 9, and then say those are all missing values. That's a pairwise deletion approach. Another way is to treat it as missing in a listwise fashion. If you answer does not apply to one or more items, you're gone. You're out of the data set. Serious problems with that are reduction of sample size and introduction of systematic bias into your data set, because you're deleting all the other responses as well. Another approach, which is a very much more sophisticated approach, is called two-part continuous growth modeling, which basically involves creating a new item. For every item that has a does not apply option, you create a new item and code it as 1 or 0. 1 if students answered anything but does not apply, and 0 if they answered does not apply. And then you include all those additional items in your analysis and incorporate that aspect of their response into the model itself. Some issues with this that we had is that it requires, as far as we know, it requires continuous data, because you can only do it using maximum likelihood estimation. And maximum likelihood estimation has assumptions of multivariate normality, which our data being categorical likely violate. So that was one problem we had. Another problem is that essentially increasing the number of items by 50% in our data set would have created a lot more complexity in our model, and we only had 235 respondents. So we were already kind of on the edge of how many people we needed to, the sample size that we needed to estimate, or get our model to estimate and converge. By doing this, it would have been a great struggle to use this. But this is something that probably needs to be done in the future. And also, we were talking there's a dissertation in figuring out how to do two-part growth modeling with categorical data, if you're looking for a dissertation topic. We believe. Yeah? I saw a nod over there. Sarah, it's yours. Okay. All right. So, I think I didn't list here was you can also use IRT to look and see how the does not apply option is functioning within that item to confirm or disconfirm whether you should treat it in one of these ways. I use these two methods to treat the data in my situation. For most of the items, 19 of these 22 items, they could be treated as meaningful within the scale, within the continuum of that item. And in all cases, they had the same meaning as the next most extreme value, like the search function. It's not there or it's not at all useful. We just recoded it as the same. So those went from having 5 categories to 4 categories. But we didn't throw out any data. For 3 of the items, the does not apply actually didn't relate to the textbook, but it related to the course. Like, my course didn't have lectures, so I can't tell you how my textbook affected my understanding of lectures or something like that. In those cases, we treated those responses as missing data. And you should know overall, out of the 10,000 cells in the data matrix, the 235 by 44 data matrix, 4% of those cells had a does not apply response in it. So it was actually quite a minor amount, a small amount of the data overall had this, and then of that, only 3 of those items were treated as missing. So we really ended up throwing out less than 1% of the data altogether, which I was happy we could do that, not have to listwise delete throughout nearly everybody, but there were other options. So a little fun measurement exercise there, huh? Pay attention to does not apply. So once the data was cleaned up and coded properly and all of these issues were handled, then we could get into evaluating that first order model. I did this in a confirmatory approach rather than exploratory approach, and I'll tell you why in a little bit. Well, maybe I'll tell you why right now. I did it that way because the point of my study was to generate, using qualitative analysis, an a priori model that I wanted to test and confirm or disconfirm. because I had that model, I had data backing that model, it made most sense to go to use a confirmatory approach to confirm or disconfirm that model. And we actually did run a number of exploratory analyses where we looked at a 4-factor model, or a 6-factor model, or an 8-factor model, and we got reasonable fit, but we lost a lot in parsimony. Those models had a lot of cross-loadings and a lot of things, and also it rearranged the items all over the place and put them into factors that didn't make much sense given the theory that we had going forward. And so, for those reasons, because we're going to stick to our convictions about that theory, confirmatory factor analysis was the approach that we took. Now, if we had found, using confirmatory factor analysis, very poor fit, a grossly misspecified model, then we'd need to go back and reevaluate that a priori model that we had. But you'll be happy to know that's not what we found. So, we use factor loadings and fit statistics and chi-square difference testing to iterate through models in the confirmatory framework, which I'll show you in a minute. So again, this was the first model, the a priori hypothesized first order factor structure with all the items written that we predicted that were designed to load on those factors, to measure those factors. And this, you can see here that all 44 items are in here. Now remember, we deleted 3 items going forward.
So that's all right.
What's that?
You want to speak to that jumble of
Oh yeah, so
correlation in the middle and
yeah, so what the arrows and the double-headed arrows going between the factors represent are covariances between those factors. Can give you a sense of whether there's any relationship among these factors. And that's all.
So simply your model specifies that all factors are correlated with all other factors.
Yeah, to some degree.
Every factor is trying to estimate to what extent each factor is correlated with each factor.
Right.
And how would that be different than just making an overall quality factor that all of a higher order quality factor that all of those
Would load on?
would
Well, I don't think
is that the same general idea?
I don't know if in that way you would get an estimate for every correlation.
Oh no.
So you wouldn't get as much information out of that. But that's essentially what we're saying. We're saying all these models are related, all these factors are related to each other, there's some global factor, textbook quality. That's the whole point here. We're saying this is a measure of textbook quality. Right.
But,
Okay?
but you're also trying to find out to what degree,
Yes.
what's correlated with what.
Right. And that in the second order model we start to get at that question. What's related to what? Right. So the process that we took here, we started with that. That was model 1. So, well, that actually wasn't model 1. Model 1 didn't have those 3 items that we removed. Right? But otherwise, it was the same. And we ran a CFA on it using an estimator that wasn't maximum likelihood. We used a weighted least squared estimator that can handle multivariate violations of multivariate normality, and got these fit statistics for this model. Do you recall CFI above 0.9 or close to 0.9 is a good value? TLI above 0.9 is a good value. RMSEA below what? Remember? 0.08. 0.08. Those are the values that we're using here. Now, yeah, so that was model 1, which actually had, okay fit. I mean, it's not down in the 0.7s, and RMSEA is not up at 0.3 or anything like that, but it's not fantastic. And also, what you get in the output from a confirmatory factor analysis, you get some information on the factor loadings that you've specified, and you even get a z-test to say whether a loading is significant or not. And there are actually several loadings that were not significant, or that were quite low. And that led to some modifications to the model, some post hoc modifications to the model based on, 1, the factor loadings, and 2, those modification indices that you get out of confirmatory factor analysis that would tell you how much chi-square fit is predicted to improve if you were to make that modification. Modification could be adding a cross-loading or removing a loading for a particular item on a factor. So these models, as you go through, are basically stepwise modifications to the model based on factor loadings that were low or based on modification indices. And my goal was to have no modification indices above 20, the value of 20, and to have very few modification indices, and to have no insignificant or low loadings on any factor. And the resulting model here, well, and so you can also test the fit of models that are nested models. You can test the fit using a chi-square difference test, which will give you a significant value if the less restrictive model, the model that has more freely estimated parameters, is a better fit than the more restrictive model, then your chi-square difference test value will be significant. Is that right, Dr. Olson? I got that?
That's right.
This is sympathetic. So the less restrictive model has, if it has better fit than the more restrictive model, then your chi-square difference test will be higher. So each of these chi-square difference tests is between the next highest model. Model 2 with Model 1, Model 3 with Model 2, Model 4 with Model 3. But the nesting relationships don't necessarily, it's not that Model 3 is always nested within 2 and 4 within 3 and 5 within 4. Those nesting relationships differ based on the specific modification that I made. If I freed up a loading or allowed a cross-loading, then that became the less restrictive model. But if I constrained it in the next model, then that prior model was less restrictive, right? So
when you're doing the chi-square difference test, just trying to like figure out what are you subtracting from where?
So I don't do this. The chi-square difference test, when you're not using maximum likelihood estimation, is not as simple as
It's not.
as subtracting the chi-square values. You actually have to use diff test
Cool.
in M+ to do it, and it will only calculate it if those models are nested, which is a great way to check whether your model is nested. When you get complex models, it's not. You can't just look at it and say, oh yeah, that was nested in that one. But if you do the diff test, and you can also look at the number of freely estimated parameters. But if the diff test gives you a value, then you can determine which one's nested within which, and all of that.
Great.
So yeah, so it's not as straightforward as all that. But anyway, what we ended up with down here in Model 10, Model 10 was very similar to Model 8, and I'll show you this. Only Model 8 had 2 cross-loadings in it, and Model 10 we removed those 2 cross-loadings. Model 10 actually has worse fit than Model 8. Model 10 is more parsimonious because those cross-loadings are gone. And in the context of what we're trying to do here, which is propose a model for digital textbook quality, cross-loadings don't make a lot of sense. What does it mean when you're scoring an instrument, and when you're trying to understand what students are thinking, to have this item be related to diversity and to presentation? You want them to, and since the fit was already really good, and the fit that we lost wasn't all that much between Model 8 and Model 10, we went with Model 10, and I'll show you that one. So this is Model 10. Some things to point out here that are different from Model 1 are the removal of those items. That's a lie. Those items were already removed in Model 1, so ignore that. I just didn't have time to build a new path diagram for it. But note that. R2 is gone, D1 is gone, and PF5 is gone. Some other differences, though, these are the key differences. This is what came out of the post hoc modification. Items A1 and A2, through those modifications, have better loading on the performance factor than they do on the access factor, where they were originally intended to load. Same with N6 here. It was designed to load on navigation, that actually loads better on performance. And then PR6 from presentation over here actually loads with interaction. And when you look at each of those items, it's interesting to look at that, especially with most of the changes over here with performance. Though N6 reads how easy is your textbook to navigate, you would think it would go with navigate. What that really is asking them is how well is the navigation technically performing for you. Whereas all of these other items asked about things like search functions and page numbers and specific features of the book, which weren't about performance, technical performance, but were more about these features. And so it actually turns out that even though this has the word navigate in it, was the only one that had the word navigate in it, students didn't see that as a navigation question, at least in the way that factor is defined as navigation, but more of a technical performance. That's an example of so in making any of these changes and modifying and choosing to say, okay, I'm going to put A1 down on performance, it was really important to go back and read the items and say, okay, is that justifiable? Can I interpret that? And in all 4 of these cases, really it's 4 major modifications, it made more sense to have these items loading on performance. Same with interaction. Yes, Sarah?
Sorry, this might be a dumb question. Is this in AMIS? Do you have these
Yeah,
analyses?
these are all, well, No, I didn't run the analyses in AIME. I drew the diagrams in AIME.
Okay,
But all the analyses were run in N+.
cause my question
So
was.
he benefited,
with
he
the-
wanted, he had his cake and ate it too.
I did,
That's
which
nice.
I'm really good at.
And we applaud you. So quick software question. In Amos, we talked about modification indices as correlated errors. Does Amos also talk about, does the modification indices for these come up as you should change the factor loadings, or does it come through?
You get two kinds of statements with a modification index. You get a by statement and a with statement. A by statement is related to an item loading on a factor.
Okay.
And a with statement has to do either with two factors being correlated or two items being correlated through the error covariances. I didn't have any modification indices related to with statements or error correlations. But you're right, in class we talk a lot about that,
Right.
but I didn't have any of those, thank goodness, because that complicates all sorts of things.
Do you know if Amos does that as well, or is that a limitation?
Does Amos give you modification indices? I don't remember.
It does for correlated errors, but.
For both, one a jump.
Yes,
We'll give it four loadings as well.
for any parameter in the model, where the implied covariance matrix differs substantially from the observed one.
Though I highly recommend N+ if you're going to do any serious confirmatory. It's not, R is a lot harder to learn than N+.
Oh, yeah.
N+ has, it has a lot it can do, but for confirmatory factor analysis, you can learn N+ in an hour. Like, you can learn how to write the model statement and all of that, and how to read the output. So, if you're seriously considering doing CFA, and I hear there are even probably better ones, like latent gold, that gets more into SEM, right?
That's more latent class model.
Latent class modeling. Okay, so N+ is a great
So I have a question. So if you learn, and this is actually more for Jared, or maybe for you, I don't know how well you know R, but if you learn R fairly well, are they comparable, or is it still a little easier to do in N+?
They're comparable, well, you can't, I don't think you can do any of this, I mean, you can probably do factor analysis in R, but it's not specifically designed for that, whereas N+ is.
But see, N+ isn't free, and
Well,
that's
the
the
R
problem.
package is designed for that.
Well, yes, the R package is designed for that, it's true.
Okay.
So, yeah, so it's not free, so if you're gonna do this, and you're not gonna be here in the building, and you wanna learn how to do it in R, probably not a bad thing, I don't know.
EIME graduate Kim Davison does CFA in R and finds, she says the M+ is still the gold standard for CFA, but for a lot of purposes that she can get utility out of what she's doing in R, and that's just sufficient for her needs.
There's another, R is free.
Yeah.
M+ is $900.
See, that's what I just keep running into, is the cost, and the ability to do it.
That's why you get hired by someone who will buy it.
So let's move on quickly, because I'm almost done here. The second order model evaluation followed an interesting trick. First we started with CFA, because we had an a priori theory about, I had an a priori theory about how these factors related to each other. But also, I was interested in doing an exploratory analysis based on what we had learned in the first order analysis. So using model 10 to do a little exploration on that second order factor structure. Find out how many factors there are according to the data, and maybe what those relationships were. So we did that as well, and again use these same metrics for evaluating. So here was the hypothesized model based on model 10. Okay, so note that R2 is missing and D1 is missing, and these are rearranged as came out of that. And so we subjected this model to a second order factor structure where I had two factors, and I loaded those four on this one and those four on this one. Two second order factors. And then we were able to do a chi-square difference test, because it turns out those models are nested in each other, because it's the same number of items and the same number of, but different number of parameter values. The same number of lower order factors as well. So here's model 10 versus model 1H. Now, always when you do a second order factor, it's going to fit worse than your first order factor. True?
The worse or the same.
Worse, oh yeah, okay, yeah, it's a good point. Worse or the same. It's going to either be, so the chi-square difference test is always the model that, if it's significant, that means that your lower order model fits better. The question I had was, did the fit reduce significantly? Did it go out of bounds? Was it very bad fit? You can see that the CFI dropped quite a bit. The TLI not so much. RMSEA went up a little bit, and this Model 10 does have better fit. But is the fit of Model 1H poor? I would argue no. The fit of 1H is still pretty good. So the question then is deciding between Model 10 and Model 1H in terms of maybe interpretability, or parsimony, or what it could mean going forward in recommendations for using the model or the instrument, which I'll talk about briefly. We don't need it. Well, I don't have time to talk about this. We had one out of range value. It was above 1. The loading was above 1. The question you ask when you see that is, how big is the standard error? If the standard error is low, that means you can reasonably assume that this is not a significantly out of range value. And what I did to solve that was I just set that standard error to 0, which basically sets the loading to 1. Which is what you do when you use the marker value approach for anchoring your... Well, I didn't use that in this. I set this to 1 to make this a plausible model, because an out of range value is an implausible model.
You mean, not the standard error is low, but the residual variance?
Yeah, sorry, the residual variance is a good catch. So, and in this case, the residual variance was low. So, anyway, I wanted to point that out. So the next step that I took was to look, once we'd done the factor analysis, the CFA on the first order, or the second order model, I wanted to do the exploratory analysis on that second order structure. And I got out of Model 10, we call a factor correlation matrix. And these are all those crazy arrows in the middle.
The spaghetti.
Spaghetti. You can use this to do an exploratory analysis, because exploratory EFA starts with a correlation matrix. So in SPSS, actually, is where I did this. I did a factor analysis in SPSS, which resulted in some values here. I said, please extract 2 factors.
So what he's telling you is, he's taking the correlations among the factors from the CFA, and he's going to now do an exploratory factor analysis on those correlations to see if there are second order factors.
Right. And so when I asked for 2 factors, so I'm only going to get loadings for 2 factors, but you can see how they come out here slightly differently. Actually, I missed one here even on the slide. Actually, this is the highest value over here. So diversity should actually load on high order factor 2 with these other 3. And it cross loads with factor 1, which won't be represented going forward, but Joe caught that today, and I appreciate you catching that. Because the sign of the loading actually doesn't matter. It's the magnitude. So either way, it's different from my hypothesis. I also ran to determine how many salient factors there were in the solution, how many of those factors matter. I ran a parallel analysis. So out of an EFA, you get a bunch of eigenvalues. You get an eigenvalue for every variable. Now in the high order structure, I only had 8 variables, because I was using my 8 factors. So I got 8 eigenvalues, and then using a simulation method called parallel analysis, you can simulate with, you enter the same sample size and the number of variables, and then it uses a simulation procedure to simulate a set of random eigenvalues, right? And you do that 10,000 times, and you can take the mean of all those eigenvalues, and you can get what eigenvalue you would expect based on your sample and your number of variables by chance. And the way parallel analysis works is you compare each pair of eigenvalues, and any eigenvalue in your model that's higher than the random one is considered salient. So here we have 2 salient factors, because these 2 eigenvalues are higher than you'd expect by chance. And then by the 3rd factor here, the chance eigenvalue is higher than the model value. So we concluded that there are actually 2 higher order factors. An interesting way to use EFA to make a confirmation. So this is not what Model 2H looks like, because I missed a factor loading. This factor here will actually load over here with a cross loading over 2 factor 1. But you can see that it's different from the a priori hypothesis. Its fit is significantly worse than Model 10. And previously I couldn't compare Model 1H and 2H, but now I can, because of that because there's going to be 1 extra cross-loading. So now one of those models will be nested in the other. So I'll have that in my final dissertation. Again, we had that out-of-range value that I handled in the same way. So, which
Brown
bear?
bear.
What?
Brown bear.
Brown bear. So, which model is preferred? Which model should we go forward with? This is the question that we're trying to ask. I was trying to answer. There's this model, door number 1, model 10, the first order model. There's model 1H that explains the relationships among those factors. There's model 2H, which is incorrect, which is similar to this, but actually is going to be less parsimonious when I make those changes. Okay? And will kind of fly in the face of the a priori theory. And I chose, without any further ado, model 1H for several reasons. One reason is that it has reasonable fit. A second reason is it explains the relationships among those factors, which can be useful when you're scoring results from this instrument. You have a technology factor and a content factor, which are different from each other. A third reason is it's more parsimonious than the other second order factor structure. And then there were some other reasons as well that I didn't write down for some reason. But those are the main ones: fit, interpretability. That's it. Compared to model 2H, it's more interpretable. These factors make sense according to the theory that we had. When you start throwing diversity over here and performance over there, it becomes unclear why those things go together and what commonality they have. And since this is a reasonably fitting model, I didn't find justification to throw out my theory just so that I could get a little bit better fit. So, related to the questionnaire now, and this is the final thing, I did look at the reliabilities of each of those subfactors: navigation, access to diversity, which were all quite high, and the reliabilities of the second order factors were high as well, which just gives evidence that this instrument's probably ready to use right now. It needs refinement, but